Right. Okay, so thank you for coming. We are going to listen to Claudia HEMP from favoured. Claudia is working on the Orthoptera of Eastern Africa, especially the tigonids, but also grasshoppers, on the taxonomy, the phylogeny, with the molecular and morphological characters. And there is a whole team which is working on these insects, on their evolution, their phylogeny, their distribution. And finally, it's a very interesting project on the biogeography of Eastern Africa and the way these insects have speciate according to habitats, according to elevation. And so it's a very powerful research project to analyze biodiversity in this particularly rich region. So we are listening to Claudia and Speciation mechanism of East African orthoptera.
Thanks very much, Laura, and thanks to SYNTHESYS of inviting me and giving me a grant coming to Paris. As Laura said, I want to give you an overview of research of the past over 30 years in East Africa. And also, as Laura said, we are a whole team of people working on it, contributing to the data I'm presenting now. We are working in East Africa. You see Africa here, and here an old German map. And very important is to understand that you have very old mountains, the Eastern Alp Mountains. Maybe you have heard of them. It's a hotspot of biodiversity and endemism, listed among the world. And they are very close to very young volcanoes. Young means 1 to 2 million years. I want to show you exemplarily how we worked there, and that it is important also to look at habitats. Here is a drawing of my husband from Mount Kilimanjaro, which shows you the elevational zones you find in East Africa. You have a colline zone, a savanna zone, you have a submontane zone on mountains with special vegetation, you have a montane zone. On Kilimanjaro, it's still forested since it's a national park. Above the forest belt, you have a subalpine zone, also important for Orthoptera, but above that, at least nothing interesting for me. I show you the zones with some pictures. This is East Kilimanjaro, Lake Chala, a very beautiful lake. And we have a very high diversity of Orthoptera, of, I guess, all arthropods there. They're widespread Orthoptera, but also you find immobile endemism. We climb up, we go to the submontane zone, and you might think here, okay, it's still forested, but this is an agroforest system typical for East Africa, which is densely populated by people, up to 5 to 1,000 people per square kilometer. And here already you find endemic species in Orthoptera, but also fully winged ones. We go into the montane forest, which is, I guess, unique. It's very nice, still intact on Kilimanjaro. And everybody you find here is flightless. They cannot fly anymore, and they're endemics to the mountain. We go up. We go to the Afro-Alpine zone, known to many people, I think, because of their charismatic plants. This is Dendrosenecio, but you also have these giant lobelias. And everyone living here in Orthoptera is an endemic to the mountain. I'm not working alone, I'm working in a team. Important is Klaus-Gerhard Heller, he's doing the acoustics of those who sing. And Elzbieta and Beata, I have a decade-long collaboration doing chromosomes and the phylogenies. And also we had some master and PhD theses contributing to the results. Very important is my husband. He's a botanist and also looking at the climate, which is, I think, one mango maybe in zoologists that they partly look at the vegetation. Here is an example of a flightless species, an endemic to the Mount Kilimanjaro area. And you see it is plotted the elevation against the precipitation, the amount of rainfall. And you see that this species only occurs in a very defined niche. So it's very important to know also the ecological demands. With my handy dazu. To study the speciation mechanisms, you need some conditions there. You need insects or a group with a low mobility, of course, with a defined habitat. And of course, you would need more than one species in that group. And I will show you examples of Epistaurus. These are small grasshoppers. I will go to bush crickets, flightless bush crickets, two genera here, a group of also conocephalines of small bush crickets restricted to East Africa. And here, I think it's the most charismatic group, Aerotegmina, which is also restricted to Tanzania. This is Epistaurus, for example. This is Afroagretia, Afroanthracites. This belongs to the Calmialina, these small conocephalines. This is an example of Aerotegmina. Why is, especially in this region, such a high degree of endemism and a high diversity? This is the question behind our research. And the current scientific opinion is that a stable climate and a long time of isolation favors speciation and the high biodiversity. The coastal forests of Tanzania and Kenya are thought of being many millions of years old due to a stable climate from the Indian Ocean. And the Eastern Alp Mountains, which I showed you in the beginning, are thought to be more than 30 million years old. Here's again this map. We see these Eastern Arc Mountains, North Para, South Para, Zambara Mountains, and here would be the coast. And these are the young volcanoes on Kilimanjaro and Mount Meru, and some more in the Rift Valley, which are 1 to 2 million years only old. And in this area, you find isolated montane forest patches on each of these mountains or mountain ranges. So I will show you 3 pictures from the area so that you also understand, if you imagine the picture I showed you of the montane forest, and if you see a habitat like this is in the North Para Mountains, you can imagine that somebody is not very able to crawl over to the next montane forest patch. So they're really isolated. And we addressed the following questions. Are the old coastal forests the species source of the array of species we find further inland? During which time happened this diversification? And do we also have archaeoendemics in the area because the area is so very old? Which role play the topography and climatic fluctuations for the whole processes? And which role did river courses play in the area? And which role does the ecology of the species play in this context? So this is the first example of these small guys here, flightless, as you see. They have reduced wings. We made a molecular phylogeny. You see it's going back to 10 million years, and as it is well known, Africa dried up from 8 million years from here. But what is also important for the speciation processes are these humid periods, which are drawn in here like this. And I also included this brownish or orange bar, which shows when the volcanoes popped up in the process of the Rift Valley. Yes. So you see at the base of the tree, really there are coastal species. If you go inland, you find a mix on young volcanoes and the Eastern Arc Mountains of being very old. So what is also shown here is that at each of these humid periods, you see that the genus diversified. They were isolated during the dry periods, and once it got more humid, there was an explosion of species with each humid period. One example, Epistaurus nairobi is a species distributed in the Kenyan highlands, and this probably only spread when the volcanoes were already there, serving as stepstones. Before, the Kenyan highlands was not populated or not, there didn't occur a species of it. And alone on Mount Kilimanjaro, the young volcano, we have two species of Epistaurus, and you see the first one came with the first period. Its sister taxon is in the old North Para Mountain. Second species, it came during the last humid period. And also he has a sister species in the old Eastern Arc Mountains. So you can see that this is a very young radiation, which you see here, and has nothing to do with the old age of the Eastern Arc Mountains. It happened during the past 1 to 2 million years. Somebody talking here?
Excusez-moi, tout le monde vous entend. Est-ce que vous pouvez couper votre micro, s'il vous plaît? Encore.
You have to do something?
No, we will see.
We switch over from grasshoppers to bush crickets, completely different group. And we also, it's the Agrazzini, which I showed you in the beginning, small guys, also very immobile. And we did a molecular phylogeny. We found several groups. Missed, it gets to it. We see that those of one genus are monophyletic, and the African taxa are also monophyletic. The next sister group sits in Australia, then representative of Asia, and Madagascar is really far away. So Madagascar has probably not much in common with the mainland African species. We look at Afroanthracites. You see, flightless, they have wings, but they are unprotected under the pronotum. We have 16 species in East Africa and many more. I wouldn't be surprised to find something here as well from these groups. And you have the same pattern as Epistaurus. You have sitting them on the young inland volcanoes and the old Eastern Arc Mountains. What is very conspicuous is that you have morphological sister groups. You see these guys, they look very similar. We look at these two pairs. This is Afroanthracitus monsium, and this is Usambaricus. This sits on Mount Kilimanjaro. You see the genitalia here, and from that in the Eastern Arc Mountains, which should be very old, and that they are very similar. You really have to look if you catch them in the field. You just know you're in the Usambara Mountains, then it should be this one. On Kilimanjaro, we have this one. We did a molecular phylogeny, as you saw before, and we also did a time scaling or molecular clock. And you see that Afroanthracitus monsium from Kilimanjaro, from young Kilimanjaro, is the sister group to all those in the Eastern Arc Mountains. Kilimanjaro is not older than 1 to 2 million years. So you can say with this taxon, this speciation is not older than the mountain when endemic species sits. The theory is that probably it evolved in the West Usambara Mountains, the old mountains, of course, and probably the river system of the Pangani facilitated a spread further inland. If you remember, once it was more humid, that forested areas were connected down to the lowlands, enabling species to spread. We look at the other morphological sister pair, discolor and pseudodiscolor, both in the West Usambara Mountains. So if this is 1 to 2 million years old, how old is this split? So it has nothing to do with the old age of these mountains. It's a very recent speciation inside an old mountain range. Something also to the morphology in combination with the acoustics. As you have seen in the phylogeny, those with reduced or long wings at the base of a phylogenetic tree, mostly these species sing in the ultrasonic range. This is Afroagraetia. Then when we look at Afroanthracites, the wings are under the pronotum, are not seen. And what happened morphologically is that the mirror area was enlarged because now it is protected by the pronotum. You see the mirror is very small here. But also Afroanthracites monsium on Kilimanjaro and Usambaricum, they still sing in the ultrasonic sound. Further step, the youngest sister pair, which I showed you, have much more enlarged mirrors under their pronotum. And those species, if you go to the field, you hear them. It's not ultrasonic anymore. Now you might think, what is it all about ultrasonic and being able to hear low frequency songs? It's just simple mechanics or physics. Ultrasonic songs are not penetrable through a vegetation. So one sitting in a center has not a very big range. But once you evolved a lower frequency, you can call much farther. So those immobile females sitting nearby can hear you much more easily. So this is a clear advantage in the evolution for low frequency song. I don't know whether you also have something like this in crickets. But of course, you need to transform your mirrors and your singing organs. We look a little bit closer at Afroagraetia, the taxon which have still longer wings, as you see here. We find the same pattern again. Coastal species have long wings. Further inland species have shortened wings. But there is an exception. We also have 2 long-winged species in the Eastern Alp Mountains. So this, again, could be explained by the major river systems here in Tanzania, the Wami River and the Rufiji River. During these fluctuations, species from the coast directly moved inland. So the same mechanisms as, for example, for Afroanthracites and Paepistaurus. So again, here you have the hint that rivers do play an important role in the spreading of species. In the beginning, I said that because it's so old, people think there must be archaeoendemics, and actually we found something which gives a hint to that. This is a newly described genus of false leaf katydids of Pseudophyline, Pseudotomias, and in the meantime, I have found 7 species alone in Tanzania. And if you look at the closest relative, at least morphologically, it sits in West Africa with a couple of species. I have described 2 species in this taxon. You see there are 7 mentioned. I'm not able to do this morphologically because they're so similar that we would need a phylogeny or look more at the songs and so on. So you see the same pattern again, maybe an old taxon, but the radiation you see now is very young. Yes. Another nice candidate is this one, Euryastis. Already Rage, very famous bush cricket researcher in England, said this guy has no close relatives in the whole of Africa, and it sits in the Usambara Mountains. I have found more than 1 population now, actually also in the nearby Eastern Alp Mountains. And there is nothing which you can compare it with. Even the song is very special. So you have an archaeoendemic here. So to summarize what we postulated in the beginning, are coastal forests the source of species? For those which we investigated, definitely yes. I showed you that hopefully for Paepistaus, grasshoppers, and bush crickets. And it was supported also by the molecular phylogeny. And during which time scales happened the diversification in the area? Since we have Mount Kilimanjaro as a very nice marker, and if you find an endemic sitting here, which has a sister taxon in the nearby Eastern Arc Mountains, you can definitely say this is a young radiation. But with Pseudotomias, with these two genera, and Euryastes, we also have archaeoendemics in the area. And I hope I could show you that humid periods were very important by these mechanisms in the area. Humid periods triggered a spread of taxa, while when the Africa was drying further up, speciation on the mountains in the isolated patches happened. This was shown for Paepistaurus and the bush crickets. I showed you also with Paepistaurus that probably once these huge mountains like Kilimanjaro, Meru, there's Hanang in the area, or even Mount Kenya, when they popped up, they served probably as stepstones for the spread of taxa further west. And I also showed you that river courses have an important role in spread of taxa in the area. I will switch to those small conocephalines, conocephalini. When we started this research, only a couple of species were known, but once you go collecting in the field, you find them almost everywhere. And we studied their habitat demands, their biography, their morphology, and we did a molecular analysis. We found 6 lineages in morphology. But mainly, as in many Orthoptera, also crickets, you look at the male genitalia, and we found these genera confirmed in the morphology. When we looked at the habitat demands in East Africa, we found that Carniella is a western-bound taxon in Uganda and maybe in the Congo basin. It's a forest taxon. Then we have 2 genera, which you mainly find in savanna habitats. We found Fulvus cirtis. This gene is only in submontane elevations. Melanus cirtis speciated in the Eastern Arc Mountains, and they are on forest clearings. And the most species-rich genus is Flesirtis, which is completely montane. So they all showed different habitat demands. And when we made the phylogeny, it was just the same, that all the genera clustered very nicely together. So the morphology is 100% congruent with what we found in the phylogeny. And we found at the base of the tree, we found the forest taxa. So you can also assume that once Africa was not drying up, these taxa were forest taxa and gave rise to those things which inhabited the savannas, and in a second step went up the mountains again. If you project the phylogenetic information on a map, you see that, as I said, Carniella is a western-bound taxon, is at the base of the tree, giving rise to Curtus cirtis, which is a savanna inhabitant, maybe to once the first savannas were developing in East Africa. And from this taxon, a forest taxon again arose only in the Eastern Arc Mountains, small blackish things. We found only species of this taxon here. And again, we have not many, I must admit, many information on Acanthus cirtis. It's very widespread in East Africa and occurs in the driest areas. So this also developed from a forest taxon into a savanna taxon. And now it's really a mess. If you look at Fulvus cirtis, it went up probably from Manchester to the mountains in the submontane zone, and Flesirtis is really coming, going, probably with all those humid periods spreading in the montane areas of Africa. So Yes, to understand this is not so easy. But you see that a lot happened in the past in this group. So I like this group a lot. I think it's quite charismatic, at least for people liking insects. This is the genus Orthoptera. We have 2 large species and 3 small species. They are all restricted to Tanzania, I think, in southern Kenya. As you can see, they cannot fly and they are highly adapted for acoustical communication. We investigated, or Claudia did this, the songs a lot. I will not go into depth in this. It's very fascinating. It's one of the loudest songs insects can produce. And they're only present in all those forests, especially the small species. If you come to Kilimanjaro, as soon as the night sets in, you hear chip, 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 chip everywhere. Sorry. And this is the distribution pattern you see. 1 species is very widespread. 2 species are restricted to the Eastern Arc Mountains. These are the small species. And these are the big species, 1 sitting at the coast and 2 further inland. This is the big, one of the big species. You see, they are predators. You can feed them easily with other grasshoppers, can keep them a while. And they are called whistling grasshopper, whistling bush cricket. What do you think that such a thing does such a sound? Don't imagine this now, but it's really true. Yeah, definitely. We also did recently molecular phylogeny, and hurrah, again, morphology is congruent with the phylogeny. Big ones here, small ones here. And the next relatives sit in the Indian Ocean. Silver provided material therefore, which was very nice. And the next related, or the basal taxon, is Hexacentrus. I will show you a picture just now. This also, again, you have the same mechanisms: long-winged, short-winged, short-winged. So this is congruent again with morphology. Elżbieta Banka-Lostas-Liwa, my colleague, did the chromosomes, and we found something curious here. We found that the most modern taxon had quite a basal number of chromosomes in Orthoptera. The higher the number is, the more basal they think it is. And the big ones, they have a reduced number of chromosomes. This is sometimes explained with a restriction of habitat and so on, but at least for me, it's not very well understood. So here again, a basal chromosome number in the small ones and the more modern one in the big ones. And if you transform this again on the landscape, maybe this is in Hexacentrus, you see the long wings. This occurs in the Congo basin. The diversification agrees quite well with the split up of the forests in Africa. When the forests got drier, that was the major fragmentations of a once continuous belt in Africa. Probably the ancestor of Orthoptera got trapped in the coastal forest, maybe. And again, now recently, the river systems facilitated a spread of the big ones to the Eastern Arc Mountains further inland, and the small ones all occur further south, probably also going along Pangani River system. The small ones hopped into the Eastern Arc Mountains, here South Taita Hills, and gave rise. Once Kilimanjaro popped up, and all these are mountain or volcanoes in in connection with the Rift Valley, and then this taxon was able to spread as far as Mount Kenya. I named it Kilimanjaro. I thought it must have sitting on Kilimanjaro, and then we found it up to Mount Kenya. Happens. So the aridification of Africa created savanna habitats and led to the isolation of once the continuous forest cover in the bush crickets of the Carniolina. These were dwellers of the grass and herb layers, and they adapted very quickly to savanna habitats, and secondarily they inhabited again mountain habitats. Orthoptera is and was probably since ancient times a canopy dweller, and maybe it adapted from there, from lowland forests to mountain habitats in East Africa. Just a short outlook. We also start now looking at fully winged things, not only with a low mobility. These are very beautiful, I think, bush crickets, which are restricted to Africa, Eurycorypha and Plandia. This is the taxon why I'm here in Paris. You have tons and tons of material with a lot of new species. Up to now, Eurycorypha has 55 described species, but I think after we will finish it with Bruno Massa, we have much more than 100 species. Alone here, I found about 10 to 50 now, and I haven't looked even at half of them. So what is special is even fully winged species, you have a mix of restricted endemic ones and widespread species. We have clear morphological lineages. I will show you one example. And very cute nymphal stages. Just to enjoy you, I show you the nymphal stages of Eurycorypha. They hatch as little small ants, and they even behave like ants. Even when sitting, they do as if I'm an ant, I'm an ant. We were discussing what is the reason behind it. Is it chemically? Is it just optically? And they stay like this till stage 3. This is an L2, second stage. They gain a little bit more color in their bellies. This is the stage 3. And then all of a sudden, it's a miracle, I think, physiologically, they turn to camouflage. I'm a leaf. And also stage 5 is a leaf. And the adults are perfect leaves. Hard to see. Isn't this amazing? So one example for a morphological lineage, if you look at the last abdominal target, it has such thorns or forks here. An undescribed species from Congo. We described this one from Tanzania and the highlands of Kenya. We described this one from the coast and the Eastern Arc Mountains. And a colleague, Naskreki and Buddha, just recently described the one from Mozambique. And you think they look very much the same. This also gave a lot of trouble for Eurycorypha. Some species were thought of being very widely distributed. You would, maybe not this one, but these 3 you put in one pot. But all 3, we got the songs, and they're completely different. So summary, the coastal forests of Tanzania and Kenya served as species sources. Rivers were important as corridors. That most radiations are younger than 2 million years old. And these radiations were triggered by climatic fluctuations of the past. We have some archaeoendemics, but the most processes you see are geologically young. And the aridification of Africa created the savanna habitats. I showed hopefully for Carniolina that they adapted to savanna habitats and from there to mountain habitats, while Orthoptera just adapted from lowland forest to montane forests in the area. And in Eurycorypha, I presented a morphological lineage which follows a latitudinal gradient in the morphology. Just a note to some books we are compiling right now. Volume 1 to 5 is finished, is published. Oh, sorry, 5 is published. We are with volume 6 now. It's my colleague, Hugh Rowe, a very old guy now in his 90s, who's still doing this work together with me. And there is a book which was published 2 years ago on bush crickets of Kenya, of parts of Kenya and Tanzania. You forgot it, is it?
Yes,
No problem. We have 1 copy here. And my thanks to these organizations, Tanzanian authorities, the German Research Foundation, which gives a lot of money for this kind of research, my field system, and the SYNTHESYS program, of course, enabling me to visit Paris. I've been here now for the 2nd time, so it's a really great program. And the Orthoptera Society, they're also very generous to me. Thank you for your attention. So much information.
So thanks for your presentation. I was wondering, was you mentioned ability factors such as river corridors or topography, etc. And